Yesterday our focus was on square roots when we were simplifying, but as I mentioned yesterday, we can use all of the exact same properties for higher level nth roots. A couple of people asked about the chart of perfects that you were provided in Algebra 2. Since this is pre-calc, you're going to be expected that you can recognize the perfects on your own, but I have gone ahead and attached a picture of that on today's lesson, so you can use that as a resource, but just bear in mind you won't get to use that on the test. So I would say at least the lower levels of the first couple degrees, I would expect you to recognize. Sorry, I have the hiccups. I would expect you to know, I would say, the first 5 perfect cubes and the first 5 perfect fourths. So, and you should know a lot of the powers of 2 by now. So I'd like to see you be able to do those without looking at the chart. Okay, so if I want to simplify the cubed root of 24, if it was a square root, we'd be looking for the biggest perfect square. But since the index here is 3, we are looking for the biggest perfect cube. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. 27 is way too big, so we got to hope that it's 8. And 8 does go into 24. So I'm going to rewrite this as the cube root of 8 times the cube root of 3. And again, if you kind of double check in here, 8 times 3 gives us 24, so we know we have the right two things. Now, this first one is our perfect. Since 2 to the third is 8, the cube root of 8 is 2, and then I have cube root 3 left over, so this is our most simplified version. On number 14, just like how we did yesterday, if I have 2 separate radicals, sometimes it benefits us to put those together. So if I multiply, since they're both fourth roots, we can do that. 8 times 4 is 32. So now I'm looking for something to the 4th power that goes into 32. And it's going to be 16. So I'm going to write this as the 4th root of 16 times the 4th root of 2. All right. 2 to the 4th is 16. That's why it's a perfect fourth. So I get 2 here, and the 4th root of 2 does not simplify any further. So again, if you're looking at the chart, the way you would want to do this is, since it's a 4th root, you would go to the 4th power column and look on that column for the highest power or the highest number that goes into, in this case, 32, or whatever the radicand is that you're trying to work with. Quotient rule here, same thing. I can split this apart into 2 radicals, since 16 doesn't go into 81. And these both happen to be perfect fourths. 3 to the 4th is 81. 2 to the 4th is 16, so 3 halves is what we get. With adding and subtracting, we have to have like radicals first. So I'm hoping that if I simplify this, I'm going to get a cube root of 2, and that's exactly how it works out. The 16 is going to be 8 times 2, and 8 is the perfect cube. So 2 is the cube root of 8, and then since I have the 2 left, that's going to give me that. So you can see now I have cube root of 2 and cube root of 2. Those are going to match. So I do have my like radicals. I need to multiply the 5 and the 2 here, so we get 10 cube root of 2 minus 11 cube root of 2. And when I subtract, that gives me negative cube root of 2. Now, remember, that's a negative 1, but we're in pre-calc, so we need to not write those things that are redundant anymore. If you put those in MyMathLab, it's going to count it as wrong. So you just want negative cube root of 2. We don't need the 1. All right.